In part 2 of this series, where we learn how to measure energy change in a bomb calorimeter, we ended off with question number 2. And question number 2 reads, when 1.550 grams of liquid hexane, which has the chemical formula shown there, undergoes a combustion in a bomb calorimeter, the temperature rises from 25.87 degrees Celsius to 38.13 degrees Celsius. Find delta E for the reaction in kilojoules per mole of hexane. The heat capacity of the bomb calorimeter, which is determined in a separate experiment, is 5.73 kilojoules per degree Celsius. Let's start off by writing out everything we know. This question is very similar to question number 1, so if you'd like a challenge, make sure to wait for question number 3, which will be shown soon. We're told the mass of hexane, it's 1.550 grams. We're also told the start and finishing temperatures, so we can find delta T by subtracting 38.13 degrees Celsius from 25.87 degrees Celsius. We'll do that in a moment. In addition, they've told us what the heat capacity of the calorimeter is, and I'll represent that as capital C sub CAL is equal to 5.73 kilojoules per degree Celsius. To find out delta E, we need to find out the heat of the reaction and divide that by the number of moles of hexane. I'm representing moles with the letter N. And to find out Q sub Rxn, we use the same formula we used in question 1, which is shown right here. We're told that the heat absorbed by the calorimeter is equal to the heat released by the reaction. And to find that out, we take C sub CAL times delta T. Let's go ahead and do that. Let's find out what QCal is equal to. QCal is equal to this number, 5.73 times delta T, and we can find that out using our calculator, 38.13 minus 25.87. We end up with 12.26. Multiplying these out, we should end up with the amount of heat absorbed by the calorimeter. The number that we have on our screen times 5.73. This gives us 70.2498. 70.2498. We should stop at 3 significant figures. I'll put a dot underneath this too, but I'll keep those following numbers just so that I don't run into rounding errors. This number is equal to negative Q of the reaction, and that makes sense because the calorimeter is absorbing the heat, and what's releasing the heat was the burning of that molecule. So this number should be negative. QRXN is equal to negative 70.2498, and that will go right there. Now we need the number of moles of hexane, and to do that, we need the molar mass of hexane. The molar mass of carbon is 12.01 grams per mole, multiply that by 6, plus 1.01 for hydrogen, multiply that by 14. Let's find out what this is. 12.01 times 6 plus 1.01 times 14. And we end up with 86.2 grams per mole. Now if I take the mass of hexane, 1.550, and multiply it to 1 mole per 86.2 grams, the grams unit will cancel out, leaving us with the number of moles. 1.55 divided by 86.2. This gives us 0.01798, and the units are in moles. This goes over here. Our final answer should have 3 significant figures. Let's go ahead and figure this out. Negative 70.2498 divided by 0.01798. We end up with an energy change of negative 3,907. This should be 3 significant figures, so our final answer should be negative 3.91 times 10 to the power of 3 kilojoules per mole of hexane. That's the answer to question number 2. If you'd like to see the answer to question number 3, which is the more challenging question, feel free to watch part 3 of this series. We'll see you soon.